Hello Harlem Lacrosse students. In this video we're going to take a look at assignment J4 from the Algebra 1 curriculum, the one that's about solving two-step linear equations. So our equation, which I'll just go ahead and read, this is just building on the previous assignment which had you solve one-step equations. As the assignment title suggests, solve two-step equations means they're a little more complicated. It's going to take a couple steps if you are using this algorithm method, and you'll also find if you're figuring it out like a puzzle, the inspection method that we've talked about, it will just be a little more complicated to think about because there's two steps of mental math to kind of do. So our equation, which I'm going to put a box around, says 3t plus 9 is equal to 18. I'm going to also draw the river or a quick little line through that equation. And what this statement, or this equation, is really saying is whatever 3 times t plus 9 makes, it better make 18. So I'm going to first talk through this with inspection. I think this equation is simple enough to think through with inspection. And then we'll also show on my whiteboard how to use the algorithm or a step-by-step process. So here I know 3 times t, whatever it makes, when I add 9, needs to give me 18. So if I'm thinking about this like a mental math puzzle, it's really saying this block plus 9 better give me 18. And I'm going to go ahead and put in green here, this block then, the 3t block, needs to be 9. Because 9 plus 9 would give me 18. So I know what number times 3 would produce that 9 that I need here. I know 3 times 3 would give me that. So if I'm thinking through this with inspection, I know 3 times 3 would give me 9, and 9 plus 9 would give me 18. So the answer, the solution, is t equals 3. I'm going to show you that now with the algorithm, the step-by-step process, by writing this equation out and simplifying that equation. When we say simplify, our goal really is to get the equation so simple that the variable, in this case t, is all by itself on one side of the equation and just equal to a number. So my goal is, where is the t located? In this case, the t is in the left expression. It's part of this 3t term. So I want to get rid of any other term on the left expression. In this case, I want to get rid of the positive 9. I know inverse operations, subtracting 9 could get rid of that positive 9. And by doing that, my equation would be simplified so that the t term, the 3t term, is now the only thing on the left side. But I need to remember, very important, anytime I change one side of the equation, I need to change the other side. Or in this case, I need to subtract 9 from both sides of my equation, and 18 minus 9 will give me a positive 9 on the right side of my equation. And now this, you can see how this is very similar to inspection. By this step-by-step, it's gotten us to a similar spot that we got to by thinking about it mentally over there. 3 times t equals 9. At that point, anytime you're using this step-by-step process, you don't need to write out the last steps if you know the answer. And here I know 3 times 3 would make 9, so I know t is equal to 3. If I didn't know that off the top of my head, the opposite of multiplication, the opposite of multiplying t by 3, would be to divide both sides by 3. And 9 divided by 3 would give you that same 3 that I just kind of got by doing the last step mentally or by inspection. So as you see, we call them two different methods, but they do have a lot of similarity. One is just kind of simplifying the equation, the puzzle in your head, and the other is using this step-by-step process that helps you get there. Anytime I can use red, the inspection method, to be honest, I do that, but keeping in mind, building this step-by-step process will be important as these equations keep becoming more difficult as we move through the summer. So go ahead, plug that answer in. I'm going to erase some of my work first, plug that answer 3 in, and then we'll keep on moving to the next one. For our next equation, it says 2k minus 5 is equal to 3. So I'm going to go ahead and solve this out by the algorithm. Feel free to keep trying to do any of these by inspection, but I'm going to switch over to using the algorithm most of the time at this point. Our equation says 2k minus 5 is equal to 3. I'm going to draw a river or a line through that equation to help me focus on the left expression versus the right expression. In this case, I'm looking for my variable, the k, and the k is sitting on the left side of my equation. It's in this 2k term, so the first thing I want to get rid of is the negative 5, the other term that's in k's expression. The way I get rid of a negative 5 is the inverse. The opposite of negative is a positive, or the opposite of subtracting is addition, is another way to think about that. Either way, I'm going to be adding 5 to both sides of my equation. By adding 5, I cancel out the negative 5. I've simplified the left side so that all that is remaining over there is 2k. And now the right side is going to be the sum of 3 and positive 5, which gives me 8. So 2k is equal to 8. What number times 2 gives us 8? I know that number already off the top of my head. I know 4 times 2 would give me 8. So I'm not going to divide both sides of my equation by 2 here. I'm going to kind of skip that last step, solve the end of this by mental math or inspection, and realize k has to be equal to 4. Now, if you ever want to check your answer, you can plug that back in. If I plug this in, 2 times 4 would be 8, and 8 minus 5 would equal 3, just like the equation says it needs to. So that gives me more confidence to know that my answer is correct by first kind of plugging it in and doing some mental math to see if k equals 4 actually works in this equation. Okay, this time our equation says 5 is equal to 2y minus 3. We'll just keep running on the whiteboard for these here. So if 5 equals 2y minus 3, I'm going to again write my equation out. That's how I start every equation I want to solve. I'm going to draw the river or my line through the equal sign quickly. And now I can see this time the variable, the y, is located on the right side of the equation. It says 2 times y minus 3. So my job is to get the y all by itself. I'm going to leave it on the right side, but get rid of everything else. First thing I want to get rid of is the negative 3. And again, we get rid of subtraction or negative terms by using addition, because that's the opposite of subtraction. Positive 3 minus 3 would make 0. They cancel each other out. So my equation simplifies to say 8, because that's what 5 plus 3 gives me, needs to be equal to 2y. And you'll notice here, for me, a beautiful or nice thing about this river is that I just keep putting my equal sign on the river each time I take a step of math, and then that helps me keep things organized. It keeps the left terms on the left side of the equation, the right terms on the right side of the equation, which is really important because once you kind of misplace a term, the whole equation breaks. Now it's simplified. It says 8 is equal to 2y. We just saw something very similar to that earlier. We know that 2 times 4 would give us 8. And it turns out sometimes for IXL, they do give you similar problems. You'll see similarity. It's okay. They give you a bunch of problems to keep moving through. All right. Our next equation says 1 plus 2v is equal to 3. I'm going to show 1 or 2 more examples, but I think at this point you could definitely cut the video off and finish this assignment up on your own. So if it says 1 plus 2v equals 3, I'm going to do this by inspection actually, keep this interesting. I'm going to use inspection, figure it out like a mental math puzzle. It says 1 plus something, plus this 2v block, needs to be equal to 3. So I'm going to focus in very much on this 2v block. And I know that 2v block better be worth 2, because 1 plus 2 is what equals 3. And if I need the 2v block to be worth just 2, v better be worth 1, so 2 times 1 gives me the 2 I need. Sorry, I'll put that 1 in there now. All right. Now it says solve for m, and we see 12 is equal to 2m minus 2. So if we've got 12 equals 2m minus 2, we'll just write that equation out. And I'm sorry, I had a bit of a glitch with the screen brush there. But if we've got 12 equals 2m minus 2, This is another one that would be great for mental math. You see simple numbers, no decimals, and I know that 14 minus 2 would give me 12, so inspection would be my preferred method here. But if I'm solving by the algorithm, my step-by-step process, to show you all one last time, the 2m is on the right side, so I'm going to go ahead and add 2 to cancel out my negative 2. That gets me to 14 is equal to 2m. What number times 2 gives me 14? I know 7 times 2 gives me 14, so that's how I'm going to get to an answer here of 7. Plug that answer back in very quickly. 2 times 7 would be 14. 14 minus 2 would give me 12. That gives me confidence my answer is correct. I'm not going to keep running through more examples. I think at this point you get the idea. If you've got any questions, as always, feel free to email me, and you've got that email of ddoherty3 listed on your Google Classroom.